So welcome back from lunch, everybody. My name is Jeff Morris. I run product marketing here at Neo4j. I've been with the company about 2 years, and what I want to go through today is really just some graph observations that I've noticed in my time here. And you'll kind of catch on as to what I'm talking about when I start saying things like, things that people do, us, are very, very analog. And yet, the things that we're trying to do in either automating processes or making life more convenient for ourselves are often digital, right? Doing things on devices and computers, and et cetera. So what I want to ultimately do is map out how some of our customers are doing that activity, and relate it back, tie it back into why graphs and why Neo4j is actually so good at helping you get from these analog ideas, helping you get from these analog ideas into digital ones. So to start out, I like to begin with some kind of stupid story. I was raised on the space program, and what that means is in the mid-'60s, or actually from the 1960 all the way through to 2000, my dad worked in a company that makes spacesuits. Makes the spacesuit for Gemini, made the spacesuit for Mercury, made the spacesuit for Apollo, and for Shuttle. So I'm pretty well familiar with the ideas around rocket science and things like that. Actually, I own this particular framed poster of the framing of all of the mission patches that went up through Shuttle number 4. And the magazine cover here is actually during the Apollo-Soyuz timing. And the guy on the left is actually my dad, right? He's in the spacesuit, and he was actually the program manager of the spacesuit exercise. The funny thing about Fred is that he has a really big head, and he was actually part of the QA team for the spacesuits themselves, because if the helmet came down over his head and didn't bruise his nose, it was of correct percentile, right? A 95th percentile head is what he had. So these were kind of the anecdotes that I came home with. There's another really good one is at one point NASA was getting investigated by Congress about how come the space program is so darn expensive. And one of the activities was, how come we're spending $500 million on a toilet? And so Fred goes in there and actually has to testify in front of Congress and says, well, look, this is big-time stuff. This is actually quoted out of the Hartford Courant. This is big-time stuff. My toilet at home only has like 20 moving parts. This one has over 5,000. Of course it's going to cost more. So anyway, these are, like I said, these are the kinds of anecdotes that I came home with. So. Nowadays, I live here in San Rafael. I come into the city very, very regularly. Typically when I do, like the last time I was here in the Jazz Center, I think I was watching Snarky Puppy from right over there. Really great band, very, very fun. So I see a lot of live music. And you can see all my Fillmore posters here, or many of them are Fillmore and other shows. There's a Bill Graham show there. There's a couple of Terrapin Crossroads show there. So I'm fairly locally into live music here. And what I like about live music, or the way I explain it to family and friends, is that it's one of the only experiences that I can go and do where I don't necessarily know what's going to happen at any given time. I like that uniqueness. Right? I like the experience. I like the experience of being in a community of like-minded people in a crowd like that. Awfully fun. The last show I just saw was Luscious here. They're an awesome singing duo. And so if we start to look at things and investigate what my graph sort of looks like, I'll riff on what Emil put up here earlier. Whoops. Make all my arrows go. So my graph, I have 2 daughters as well. Each of them are one's 19 and one's 24. One's studying theater. The other one actually, ironically, or coincidentally, actually, that's words you're not supposed to mix up. Coincidentally, my older daughter works at Chabot Observatory. So there's that space connection again. And so as I continue to go and look at this. I'm married to Lori. She's a writer. She wrote her dad's memoir. I like live music, clearly. I got my picture of Chuck Berry here. I root for the Giants and the Warriors and the Sharks. Like I said, I live in Marin. And, well, the bummer about living in Marin and working for a company that is in San Mateo is traffic, right? So, as I drive to work every day, I started listening to audiobooks on the advice of my wife. And so I started listening to a lot of audiobooks. I've probably listened in the 2 years I've been here to about 110, I think, is what the count is. So going on, and I started to notice things about that were happening in each of these books. Actually, the first one I listened to, the one on the left there, Stephen Johnson's book about where good ideas come from, is all about this concept of adjacent possibilities. And adjacent possibilities is really actually the situation you all are in today. It's the idea of either meeting someone new or eavesdropping on a conversation and spawning a new good idea out of that conversation that you happen to hear adjacently. But this phenomenon happens all over the place. It happens in social networks. It happens in nature. It happens in science. So this idea of getting things close to each other and then finding what their common connection is going to be is a very, very graphy kind of idea. Back to my space theme, I like, the right kind of crazy is all about the JPL's delivery of a space explorer to Mars. Thinking in terms of maps, The Burglar's Guide to the City is actually a really interesting kind of play on that. It's how do bad guys get in and out of buildings and banks and areas where they want to go and rob? And then how do the cops figure it out? There's connecting with people. There's a Scott Adams book on influencing people called Win Bigly. It's all about the 2016 election. And then there's Carmen Gallo's books on how to do a good, effective presentation, communicate well with people. There's other great ones, right? Dan Lyon's book on startups at HubSpot. He writes for Silicon Valley now. The one I really like is Todd Rose's idea of this notion of the uniqueness of individuals. And one of its anecdotes in there is the Air Force, when they transitioned from propeller-driven airplanes to jet planes, they wanted to figure out how to retrain all the pilots and how should they accommodate the pilots. Well, when they built a cockpit for the average pilot based on readings they took from physical measurements they took from 500 different pilots, they discovered that the average cockpit didn't fit anyone, right? So this notion, and their conclusion was, well, that's because every single person is built differently. They are all unique in some particular ways. And therefore, the book goes on to describe why averaging out your SAT scores is a bad idea, why education should be highly personalized and tailored to people, and in the case of oftentimes what we talk about, why generating offers and identifying kind of commonality and similarity across the board is maybe too sweeping, and that's why your algorithms don't match as to what you might expect. But narrowing in and getting better context might be a better manner there. Talent is overrated is really just the 10,000 hours kind of practice preaching. I like Jim Gaffigan's book about traveling around the United States and discovering all the different foods there. But his thing is a trek, it's a journey, is following paths, following different areas. And then the last two that really kicked in for me are this Revenge of Analog book. And it starts out with, why is everybody buying vinyl albums again? Right? And a lot of the rationale for that is, well, it's because not only is the fidelity oftentimes better than what you get out of digital music, maybe not quite as good as this room, so it sounds better, but it's also tactile, right? It's something to hold, there's liner notes, there's things to read, there's artwork on it, there's something highly visual. So this notion of appealing to multiple senses for an individual is also ultimately a very graphy idea. And the last one is Jake Knapp's book from Google Ventures on how to build a product or run a sprint in like 5 days. and how to execute that really, really effectively across all kinds of design ideas and all kinds of product ideas. So what I'm going to end up doing as we start to talk about this, how do you get human behaviors, which are very, very analog, into the graph and do clever things with it. That's kind of much of this is ideas born out of these particular sets of books. So as I'm going to go through this, I'll talk about some of these analog styles of activities that that had kind of triggered my adjacent epiphany. We'll talk about analog to digital styles of applications and where our customers are actually delivering upon those. We'll talk about the notion of graphs starting to get layered one on top of the other, one serving as perhaps a knowledge graph, that knowledge base that Emil talked about this morning, and another one as kind of the operational or the decision-making graph living above it. I will touch really quickly on graph design thinking, but that's only to make you stick around to the end of this, to the end of the day, to see Alessandro's story about what it's really like to live inside of a Neo4j Innovation Lab sprint. And then I'll kind of close out with some of the additional customer observations and activities that folks are doing that really tie these concepts together. So about I don't know, maybe my 6th week or something like that when I was here at Neo4j, and I'm reading I'm reading the original graph book, and I'm trying to get my head around what we sell, how we want to bring it to market, et cetera, those kind of things. I said to Emil, I'm like, have you ever noticed that most graphs all have people in them? And he looked at me he's like, really? And and while it's not every graph, but pretty much all of them, or a large percentage of them seem to have people in them, was my first observation. And so they could be customers, they could be users, they could be administrators, almost any, in the organizational hierarchy you see there, your entire org chart. Your product subscriptions, you've got a user, and your network operations, you've got probably customers and users on that. And even of course, social networks are all about different people and their attributes. But then we started to explore this even more, and there's other graph use cases that were being presented to me, like this notion of POL, people, object, location, and events. Well, this is first applied towards a law enforcement use case of how the cops can do a better job of both assessing what happened and then diagnosing that, taking their clues and their evidence and then piecing back together a real story. But I looked at that and I'm like, that's actually happens more often than you think in the graph. So carry this thing forward, and one of the earliest examples that we're exploring is this advertising technology firm in New York. And what they started to do was build a graph that housed 90% of households in the country, which means that was probably about 270, 280 million households that they're mapping. They're mapping what devices you own, what you're looking at, what advertising cookies are popping up, and then building a graph out of that to help their advertising network deliver more appropriate and better targeted content. Good graph example. There's a magazine publisher that we're talking to just recently as well, doing pretty much the exact same thing, trying to assemble all of their different published websites and understand that if you go to this publication or you go to that publication, how do I piece you together and identify perhaps who you are based on your behavior, your unique behavior. Another really good one was, Emil talked about the ICIJ, right? One of their members is the Columbia School of Journalism. And of course, what spiked for me about this particular use case is that these users are not very sophisticated. They're good storytellers, but they're not technically savvy so much. But what they were trying to do is figure out, how do we decide on what stories to chase? Where do we come up with the investigative paths that we can go and pursue? Who should we interview? And of course, my wife being a journalist, they want to model the data that they're using as a story. That clicked for me. And then I started thinking about, well, you know what? The notions that we're seeing in this journalism use case, and even ICIJ's follow the money style use case, which we'll kind of dig into a little bit more, is got all of these different interesting elements to it. It's got who's doing something, what are they doing, right? Where are they doing it? That's location-based stuff. How come they're doing it? What's their motivation? And how are they doing it? What's the network upon which they're operating? So I'm starting to look at all of our use cases through sort of this lens. And it really became pretty clear pretty quickly that perhaps I'm onto something. So this is the Paradise Papers data model. And it's pretty easy to read. The red thing is an officer, that's a person. They have a registered address, that's a location. They're either an officer of, connected to, same name as, or some other entity, there's an object. And, and then there's another intermediary or other elements in there. Right? All of these are kind of fitting my mental map of how graphs actually get built. And of course, this goes back to that Stephen Johnson adjacent possibility kind of idea of, okay, so little data is good. Like on the left-hand side there, the 5 hops is okay value. But if you can explore the hundreds of hops, that's big value. It also kind of adheres to Metcalfe's law of the network. The value of your value is equal to the sum of the number of nodes, or the square of the number of nodes you have. Right? That was the Scott McNealy, the network is the computer kind of notion back when I started my career. So we started looking at these augmenting these digital activities like fraud detection under this new banner of like, all right, what's really in there? So you can do all kinds of discrete analytic things, things that you would do in SQL perhaps, looking for their endpoint ideas, what networks are they operating on, where are they going, what IP addresses are they using. Doing account-centric things is where'd the money go or where is it living. But then getting into this cross-channel or entity linking kinds of ideas around, all right, who knows who, right? What are the commonalities there? Philip Rathley, who's up next, of course, our head of product, he has a great phrase, which is, fraud has a pattern. And the challenge for our customers is finding that pattern, right, and recognizing it. So, first glance, this doesn't look like anything terribly unique. We've got 3 different account holders. They have credit cards. They have social security numbers. Each one has multiple accounts. Looks kind of normal, like any other person, until you start to reveal, wait a minute, they have the same social security number, right? That's a good clue. They have the same phone numbers, the same physical address. And again, you notice there's people, locations, objects, activities that they're doing, right? Also probably motivation that's going on there too. So it's hard to detect that when you're doing SQL activities. It's much easier to detect when you're doing graph activities. ITAL is doing exactly that. So ITAL is the biggest bank in South America. And they cover mostly Brazil, but other countries as well. They're huge. They've got almost 30 million credit cards deployed and the same number of debit cards deployed. And so what they're trying to do is build up a graph of all the people that they know, 4 million, more than 4 million people, and associate them with as many things as they possibly can. Their car loans, their insurance policies, their bank accounts, et cetera, to figure out are people opening fraudulent loan applications for a car. So what's interesting is, they have these 4.2 million nodes. That's a healthy, but not an overtly large size graph. But 4 billion relationships in that graph is pretty large, right? That's pretty big. But their aspiration is fantastic, right? They want to get to 93 trillion relationships in this graph to really help figure out what's going on in their universe. So back to my fraud diagram again, and this is really where things started to click with me. Back to that Columbia, they want to tell data stories about data, using that who's in it, what's going on, where is it happening, when is it happening, why did it go on, and ultimately, how is this getting executed, right? What network is it working on? And I'm like, oh, I see. That's why my fonts died. So we have people, locations, et cetera, in this slide. So, all right. Now I'm going to carry some of these analog ideas forward, right? And of course, when you're trying to, I guess, motivate people or influence them, trying to build a better recommendation, right? Start thinking in terms of the different senses that they happen to have about them. This is an exaggerated kind of version of the senses, right? But of course, there's sight, and and there's sound. Like I got headphones. I am, like I said, I'm an audio junkie. I have headphones. There's smell. There's taste. There's touch, right? Here's my graph algorithms book. Unfortunately, it's not available in audio yet. But it is available for free out at the front desk over here. So if you didn't pick up your copy yet, get it. Right? This is free to everybody. I think all it requires is a badge scan. But again, my tangible object, my lunch my sandwich was pretty tasty. The thoughts I've got are pretty good. The emotions I'm feeling, in terms of how Homer's doing. My bodily awareness, right, which is proprioception, right? I got to get that word down. And then, of course, what's the motivation behind a lot of these things? These are all the analogs that I'm looking at as populating the graph and then moving that into digital, right? Operating in some kind of digital environment. It could be computer networks, it could be mobile networks, it could be on your smartphone or your smartwatch, your self-driving car, whatever is going to happen next. And of course, when you start to look at the graph itself, you're like, there's all kinds of analog-y things in this, right? It's the nodes of people, right? The relationships of how they are associated with each other. The objects that they own or drive, right? Or where the car is parked, right? Those are all of the same kind of data that I'm talking about, that are built up in the graph that actually start to begin to build that context that you want for whatever you want the graph to actually help do. So let's look at some of these kind of applications that are actually these transformation of these analog concepts into digital, real applications that customers have deployed. And of course, as you'll recall, right, it's Neo4j ourselves under this practice kind of notion. We have more than 10 years experience going on at this, almost 2 decades worth of experience of this, the largest community of graph users, the largest organization of graph technologists, the most broad set of products that support graphs. And then what I really want to kind of set the framework for is, back to these analog ideas, is when you think of a graphy kind of idea, when you conceive it, right, you've got this idea of connectedness and association in your head. When you code it, right, in Cypher, you want to maintain that kind of fidelity as you move it from your brain to perhaps a whiteboard and then to perhaps the code that you're going to put into Neo4j. When it computes, you want it to behave exactly that same way, but of course be fast. And then when you actually run the application or deploy the application, all of that kind of comes to fruition. So I kind of love this slide in this context of the whiteboard being exactly what you want to be drawing, or exactly what you want to be deploying. This is your graph as you imagined it, as you defined it, as you brainstormed it, right? Turns into exactly the graph that you are you turn out in Neo4j, right? It is your whiteboard model is your physical model, it's your schema, and then it's the way you query the system. Right, so this idea, this ideation exercise, when you form up this graph, is also quite graphy, right? And oftentimes, if you're coming up with ideas, you're putting Post-its on the wall, and you're like, yeah, that's what the user requirements want to be, and assembling your concepts that way. You're circling things and connecting things. Well, guess what? You're building a graph. Cipher itself, right? The language as we go through it, matching, right? A person named Dan who's married to, whatever his Ann, his spouse, right? You're going to return Ann as the name of his spouse. That, right? It was maintaining the fidelity of what the drawn design is, right? In Cipher the language, and still being able to read it. It's legible. It gets all the way back into your head, back to the analog. And then when you make a recommendation engine out of it, which our solutions team has done recently, is come up with this idea of how, what are the relevant paths for these intelligent recommendations, right? How do you gather the data that you want to use about your customer base or your clientele or your prospects? And then how are you going to, what pathways are you going to follow in deploying one or many engines to help make that recommendation decision, right? And then using all of your available product data, demographic data, location-based data, et cetera, as your vehicle. So this is computing it as a graph. And then getting it into real live applications that you deploy and enjoy, right? Or your customers deploy and enjoy. So, and you'll notice that even in this application, once it's done, it's got people, it's got product data, it's got promos, it's got personalization, there's geolocation, can you pick it up in store? Right? It's got your payment, it's got your social information, you can share this, et cetera. All of those same graph concepts are existing in this recommendation system. Right? The graph behind this kind of recommendation engine, it's got product information, it's got supply chain and delivery information, it's got risk mitigation information, or credit check them to make sure that there's enough money in the account. And again, it's got all of these elements to it: location, people, et cetera. And guess who's doing stuff like that, right? Your favorite retailers, the most popular ones that you're very, very likely shopping in, and oftentimes very likely, like Walmart, shopping either in-store or online, right? Again, helping to bridge that in-store analog experience of you touching and feeling and looking at evaluating the products, also mapping that to your digital experience. Marriott's the same one. Emil had described this one as the pricing engine for all the hotels that Marriott and Starwood own. Right? That's a big graph. It's like they graph out every hotel, and then when they started to customize it, they figured out, oh, the corner rooms sell better, right? So we can make and the oceanside rooms, right? Price those a little higher than the internal courtyard ones. What was really interesting about this particular this use case, though, was actually which I don't think we've touched on yet, were the benefits that Marriott enjoyed out of this, right? In terms of like traffic that they were able to handle on this pricing engine, they went from allowing the hotel operators to change around their pricing schedule every quarter to doing it practically in real time, like every hour. They can adjust it based on what their booking levels are today or what they were right at this minute. So they got this 1,000% increase in their overall volume that they could handle in the system, and decrease their IT spend by half. Right? So 1,000x performance boost, significant improvement to customer experience at half the cost. Right? That's a pretty good ROI for that. So let's start to talk about some of these ideas around layering graphs, and I'll tell you about some of these customers that are doing this kind of thing. And as we set the stage earlier with this idea of knowledge graphs, right? This is your institutional knowledge, all the activity that you did before. Perhaps it's all your your scanned documents or your maintenance records of equipment. These are all elements that can help this context-rich knowledge graph. The sensing knowledge graph is what else is happening around the system, and often these involve NLP, some kind of text processing to understand what objects are in there, how they're interrelated, and then bring them forward. Caterpillar is a cool example of this. Right? This is one of those maintenance graphs or parts explosion kinds of parts assembly kinds of graphs. And what they did is they took 27 million warranty and service documents, all oftentimes handwritten. This tractor needs servicing. Replace the backhoe, scooper part. Make sure it matches the right model number for the tractor itself. and improve the predictability of when that's going to happen to all of its sibling equipment. So mapping all of this into Caterpillar's parts assembly graph. Thomson Reuters has actually spun out this particular application. This was an example of a knowledge graph being at the bottom, at the base of this system. It's kind of a slow-moving graph. It contains information about all of the publicly traded companies in the world, and then the related information about them, like who are their suppliers, who are their officers, right? What are their revenues, year over year over year? What kind of products do they build? That's part of that slow-moving knowledge graph. It changes, certainly, right? Officers come and go, that kind of thing. But it's, it's sort of the decision base for the fast-moving graph above it, which is a graph of current events delivered through the Reuters news feed, or thousands of, almost 7,000 news feeds. And what they do is they figure out, all right, what's the effect on portfolio companies that our traders are tracking based on current events? So the one I like to kind of pick on is the, or exemplify, it's even a customer of ours, is what was going to happen to the A380, the Airbus airplane, when Emirates made a decision about whether or not they were going to order more or not, right? That's the kind of real-time event that, as soon as Emirates said, no, we're not going to take any more, right? We're going to stop seeing the couple of A380s cruising around in and out of SFO. So again, a slow-moving graph living underneath a fast-moving decision graph, right? And we're starting to see that over and over again. And they start to cover lots of different data sources, right? We mentioned earlier, Amy's going to mention again your activities that you would do in your data lake, integrating more and more data to the system. Well, the good news is, and going back to that idea of the adjacency principle of one thing can spawn another good idea, graphs are hungry for data, right? So feeding them more objects gives you better fidelity, better context for these kinds of applications. Another interesting example here is a venture capital firm in the Washington area that called Incutel. And what they do is they evaluate technology vendors of all kinds, right? It's not specifically software, it's not specifically biotech. It could be robotics, it can be hardware things. So they take this collection, this amalgam of technology, good ideas that are coming out of research institutions, that are coming out of universities, that are coming out of Silicon Valley, and they look at, what are the guts of that technology? And then they try and figure out, is there a common lexicon that we can create so we can kind of create a catalog of these ideas that are getting generated, so that if I decompose into more specific elements, create the genome of a particular product offering or particular vendor's offering, then I can evaluate whether I want to invest in them as one, but then I can also disassemble that and reassemble it. They call it recumbent assembly of technology. Reassemble it into a new type of tech to meet the missions of their customers. Now, their customers turn out to be the intelligence agencies. I think spying is wrong. But their customers give them particular ideas as to what to do and what they're trying to accomplish. So the intelligence agencies are the blue dots, the vendors, the technology vendors are the green dots, and the things in the middle are actually the missions, that they are building and assembling a technology stack for, a bespoke technology stack for each particular mission. So the example I've got is let's build a drone system that can drop in a 5G network in a disaster area. And guess what? Right after we started developing this particular story, Verizon starts sending out their, we have a drone that makes a 5G network wherever you want. I'm like, I knew it. So let's start. So those are a handful of customers that are doing this kind of sets of activities. But now let's talk about what might be the process that you would go to have these ideas, to turn things into the graph of your own. And we'll use the principle of this design thinking. How many people are familiar with design thinking here? Are you guys employing it yourselves? I ask this periodically when I go out to customers. Of course, this is where it all happens. It was started at Stanford, and Google Ventures jumped on the idea. And Neo4j's jumped on the idea. So I'm not going to spoil most of Alessandro's story, but I do want to give you a sense of what it's like. A lot of it is, let's get the right people in the room, right? So the people can come from your data science backgrounds, your big data or data people, your developers who have to implement the application. But then there's also the business interests, right? Whether that's the chief officers of something or other, the people who are gathering the market requirements, et cetera. Right? So connect the innovators themselves who want to participate in this process. Walk them through the structure of these sprints, right? Day one is figure out what you're going to build. Day two is start to model it out. Day three is wireframe it and build your prototype. Day 3 to 5, finish it, deploy it, try it out with real users, gain feedback, move forward. It looks like this, right? It's a very, very graphy, analog to digital kind of process. We start with Post-its, those are analog things, and we move our way through to get that data model into a form that is indeed both digital and meets the requirements that you set out to deliver on Monday. So Amy's going to continue to talk about graph analytics and how, given your sets of data and how to manifest a graph out of the data that you already have using both perhaps Cypher for Spark or the graph algorithms themselves to identify things that she was talking about earlier, the clusters, paths, et cetera, and feed that into your next set of applications. Use the platform, right? Because the cool part about the platform now is it too is designed to cater to different types of people, right? Your developers, right? They get the development tools in Neo4j browser, in Neo4j desktop. They get the applications. They get the examples. Your administrators enjoy the same kind of sets of features. Deploy in the cloud, bring your own license. We got other cloud projects in the works right now. Integrate your data. Michael was talking about using Kettle or any other kinds of data integration tools to get the data into your graph. Kettle's, we're especially fond of that because, of course, Matt Casters, the author of Kettle, is actually one of our solution architects in our services group. So we have ready access to the guy who wrote that book, just like we have ready access to lots of people who wrote the books in their respected fields. For data scientists, we've got the more than 30 graph algorithms, as well as, and then for non-technical users, we have Neo4j Bloom, right? An experience so that people can visually understand what's happening in the graph using a drag and drop and NLP-like search kind of interface. And when you go through these exercises, a lot of these, what I've just described of doing analytics and data science in Spark, building an application that takes advantage of those algorithms and deploying it into a clever application like the eBay for Google Assistant, right? This is a conversational commerce application. Conversation, analog, commerce, digital buying. Okay? Hey Google, go on eBay and buy me a baseball mitt. Right? Oh yeah, remember, I'm left-handed. I need a mitt that fits my right hand. Context that we're talking about earlier about the people. So that's a pretty good sized graph. It's got 8 million nodes, 20 million relationships, continues to grow, and you can imagine eBay sells all kinds of products through this vehicle. So now let's take this probably one of my favorite case studies as I kind of wind down here is take this idea of, all right, you got your recommendation engine you've talked about, you got the contextualization that we were talking about on a user by user basis, but show me more of this kind of stuff. So, and of course, lots of customers, lots of organizations like yours are doing these kind of things. But I'll pick on the smart home. And the smart home was kind of inspired from a couple of use cases here from a customer in Europe, Telia, right? What they were doing was they realized, hey, I have 1 million homes with routers in them. I should, and I can get information out of my router that was actually going to improve the customer experience, in those 1 million homes. So they figured out just track the MAC address of who's got the phone, and they know whose phone is whose. So really easy to make that mapping. And then they started building clever applications inside their router platform to differentiate their routers from their other competitors. One of their clever ideas was, well, let's make the dinner party playlist based on who's in the house at any given time. We'll look at their Spotify playlists and then assemble an amalgamated one that has all of the songs from that everybody likes. So I'm like, that was a cool idea, kind of novel. Right? I pitched it to analysts, and they were like, it's a good idea, but it's just a playlist. I'm like, no, but you're not thinking big enough yet. So let's look at another one. Xfinity XFi is a Neo4j app. And what XFi has, of course, their quad play, which includes, of course, their internet service, of course, their cable content service, voice over IP for telephony, and home security. So there's your digital devices and your home security, your Nest doorbell with the camera in it, your touch-sensitive lighting environment that you've got in the house, and it's all designed to ultimately become very, very personalized to you living in your house. It'll send you a text when you leave the garage door up, right? And then you can say, "Close it, please." It will do other interesting things, like when my dad comes to visit, right? He can't hear. Get the joke? Anyway, my dad's hard of hearing. So the first thing that I have to do when he comes over my house is turn on closed captioning. But XFi will figure that out and do that for me, right? Because he has closed captioning on at his house. So this whole environment, remember, Comcast has the third largest network that they manage in the world, behind the Russian and American governments. So it's integrating, it's right now in 3 million houses, delivering this kind of a very highly personalized type of experience. So as we kind of summarize this up, the graphs driving digital innovation, just like Amy had put together the waves of how AI is evolving, graphs are evolving just the same kind of way. It started out with, your first order graph 10 years ago was, let's connect like things, people to people, computers to computers, mobile net, cell phones to cell towers. Then they started doing context path work, right? You got Google Maps out of that. It's a pretty good play. So desire for more context gives you this kind of path following exercise. Then came the idea of cross-connecting all these different objects. So that's kind of our fraud detection example. Connect these people, location, objects, activities, motivations, et cetera. And you've got recommendations engines popping out of that. You've got fraud detection engines popping out of that. I talked about the graph layering exercise that we're starting to see now, graphs begetting new graphs. That's also happening inside of our install base. As customers are like, wow, okay, that metadata model really, that I needed to deploy for GDPR reasons worked out really well. Now let's do Customer 360 on top of it. I have one slide left, don't worry. Right, and then this autonomous graph kind of set up. This is what your driverless cars is going to be doing. So, kind of wrapping on this idea of, how does a graph help me in delivering this very, very human set of analog requirements and turning that into a highly, highly digital kind of experience? It's easy, right? It's take all the things that you know about people, what their interests are, right? Where they get all their inputs, right? Look at what they're doing or they intend to do, right? The processes and activities. What are they using to accomplish that? There's other things around that will add context. And then ultimately, where's it happening? And where's it happening is location-based as well as network-based. So that kind of concludes my bit.